In this video, we're going to try to prove the following formula. So we can prove geometrically using the notion of the area that a plus b squared is a squared plus 2ab plus b squared. Okay. First, we're going to consider this small square. It has a side length of a plus b. Okay. So we know the area here of this square is a plus b times a plus b, which is a plus b squared. So this is the area which we can write as a plus b squared. We also can add these areas. So we get this first one, which is a squared, and this one here, so this is b, this is a, that's ab, the area of the rectangle. This area here is just b times b, which is b squared, and this area here, which is ab. Okay, so now we can see that we have a squared plus 2ab plus b squared. So notice that we had to add these areas. We added this one. After that, we added this one. And after that, we added this one here. Okay, now we're going to see what we can do if we have A, B, and C. Okay, A, B, and C. So what's the area in this case? The area is given by A plus B plus C times A plus B plus C, which we can write using the exponent as A plus B plus C squared. Okay, so the first thing that we're going to do is to compute the area using the areas. So the sum of the area of the small rectangles and squares is equal to the area of the square. So first we get this one here, which is a squared. Next we're going to get this one here, which is ba. Next we're going to get this one, which is ca. And next we're going to get this one here, which is ba. And the next one here is b squared. And this one here, cb. The next one is this one here, which is AC. And the next one is BC. And the last one is this C squared. If we try to write this one the usual way, we're going to have the squares first, A squared plus B squared plus C squared. And we have BA or AB is the same twice. So plus 2AB. And we have AC twice, or CA. And we have BC or CB twice. So here we have 2BC. Okay, and that's what we know. We know that A plus B plus C squared is A squared plus B squared plus C squared plus 2AB plus 2AC plus 2BC. Okay? So we can do it for A plus B plus C plus D squared. We add one more element to the game. Okay, so this is completing the square that we know already, but this is we can use this one here to compute the square root. So here we can assume that A, B, and C are all positive, but first let's see what we can do here. So here, if we can compute the square root of A plus B squared, okay, which is A plus B, because it's positive, it's going to be the square root of A squared plus 2AB plus B squared. Okay, so if we have a square that we're going to compute, if we can rewrite it in this formula, we can find this one. We can find its value. Okay? So this is giving us an algorithm to find the square root for any numbers. Okay, 36. We can write it as, because we know this. The issue here is that we know. Can we write it as some A plus B? Okay, but that's what we're gonna do in the next video. For now, we just prove this result, and we can prove this result in general if we assume that we have the sum of xi's with I going from 1 to n. So we can find a formula for the squares. Okay, so we can write it like this: the sum of the xi squared, I from 1 to n, plus twice the product of xi, xj with I different from j. Can go from n, from 1 to n, but with I different from j. So this is the general formula in the case of n variable. In the case of 2, if we have 2, we're going to have x1 squared plus x2 squared plus 2 times x1, x2, and that's it, because that's the only case when they are different, when this one is 1 and this is 2, or this one is 2 and this is 1. Thank you.